All right, so we're gonna continue on. So now we're gonna do number five. So let's read the problem. So number five say a polling agency is interested in testing whether the proportion of women who support a female candidate for office is less than the proportion of men. The null hypothesis is that there is no difference in the proportion of men and women who support the female candidate. The alternate hypothesis is that the proportion of women who support the female candidate is less than the proportion of men. Test the result of a p-value. Which of the following best interpretation of the p-value? So if you remember the p-value is that we get a value that is as extreme or more extreme than the value that we expected when the null hypothesis is true. So for this one, let's just jot down what the null and the alternate hypothesis is. So the null hypothesis is stating that the proportion of men, let's just double check that. Well, let's actually erase that. So it's actually the proportion of female is equal to the proportion of male. And you can kind of see that from this portion right here. The women who support a female candidate for office is less than the proportion of men. So that's going to actually be our alternate hypothesis. So our alternate hypothesis is that the proportion of female is less than the proportion of male. So for this one, we just want to look for something that kind of are in the line of what the p-value is. So remember, the p-value is getting a value as extreme or more extreme than the value you're looking for when the null hypothesis is true. So if we look at A is saying the p-value is the probability that the majority of men would support the female candidate. So that's not necessarily what the p-value is saying. Because remember, the p-value is saying that we're getting an extreme value or more extreme. So A is not really telling us anything of that. B is saying the p-value is the probability that the majority of women will support the female candidate. So once again, it's exactly like A, just different. Instead of saying men, they're saying the majority of women will support the female candidate. So let's look at C. The p-value is the probability of getting a result that is as extreme or more extreme than the one obtained, assuming there is no difference in the proportion. So right here, the key thing is no difference in the proportion, because the no difference in the proportion is kind of telling us that's the null hypothesis, because the null hypothesis is stating there is no difference between female or male. Because if you look at D is exactly the same thing, but in D is actually stating the alternate hypothesis. So remember, for the p-value is saying that we get a value that is as extreme or more extreme than this value when the null hypothesis is true. Since C is actually referring to the null hypothesis that there is no difference in the proportion, C will be our final answer for this one. Right. And that's it for number 5. So let's move on and go on to number 6. Alright, so for number 6, they just want to check to see if all of the condition has been met. Okay, if you look right here at 6, it says check the condition holds so that the sampling distribution of the z-statistic will be approximate. So for this one, you're going through the 4 steps. First step, they have to be randomized. So we have to make sure that the way they collected the data is random. The next thing we want to check to see if they collected enough data set. And the way that we could check to see if they collected enough data set is if we use this formula of n times p. And remember that has to be greater than 10, and n times 1 minus p, and that also has to be greater than 10. And then the final one is making sure that the data set is not big, well, too big. So the rule of thumb is that we want our data set to be less than 10% of the population. So if our population is 100, we don't want more than 10 people, because more than 10 people we have more than 10% of the population. So that's kind of the three criteria you want to look for. And well, the fourth criteria is to make sure that the data set is independent. And independent is mean that if I choose one subject, another subject, the probability of me choosing the next subject isn't increase or decrease just because I chose the other subject. So let's first read the problem and see, A, did they randomly select people? So let's start reading over here. So it said a researcher is wondering whether the drinking habit of adults in a certain region of the country are in the same proportion as the general population of adults. Suppose a recent study stated that the proportion of adults in the general population who reported drinking once a week or less in the last month was 0.26. The null hypothesis for this test is that HOP is equal to 0.26, and the alternative is that HAP is less than 0.26. The research collected data from 150 surveys he handed out on a busy park located in the region. So this is very key, because this is showing that he didn't randomly select these people. He just went to whoever is near him. Well, he just went to a park and he started handing out the survey. So this is not random. Since this is not a random collection, the data set that we get from this is not valid. So we can't use the normal distribution because the data set is not random. So we just want to look through A, B, C, and D and see which one kind of say that. So we already know A and C are not going to be the correct answer, because this one's saying that the condition had been met. So we want to look at something that says that the condition had not been met. So if we look at B, B is hitting along those lines, because saying the research did not collect a random sample. So since the research did not collect a random sample, we can go ahead and do the study. All right. And that's it for 6. Alright, so 7 kind of like a continuation of that. So it is saying assume the data set is normally distributed. So it's saying the null hypothesis though that P is 0.26, 0.26, and the alternative that P is less than 0.26. The research collected data from a random sample of 120 adults with white-collar jobs, of which 25 say they did drank once a week or less in the last month. Assume that the condition that must be met in order for us to use the N 0, 1. So remember, this is saying that the data is normally distributed. As the sampling distribution are satisfied, find the value of the sample proportion. So we want to find the sample proportion, we want to get the test statistic, and we want to get the p-value. So this one shouldn't be that bad. So first thing we want to get is p-hat. So p-hat is actually just x over n. And just remember, n is the sample. How many people did they sample? And x represent how many people of those characteristics that we're looking for fell in that. So if we look for sample, the sample 120 adults. So we put 120 in the bottom. And then what we want to do x is how many people are fall under white collar. So that's 25. So once you get those two information, we can do 25 divided by 120. So let's use our calculator. So we do 25 divided by 120. and we'll get the answer of 20.20, and we'll just say 8.2008. Alright, so the next thing what we want to do, we want to get the test statistic. So once again, this is for proportion. So since this is for proportion, we want to get standard error, where standard error is equal to square root of 0.26 times 1 minus 0.26, all divided by however many samples you have. So this one's 120. So we do second radical 0.26 times 1 minus 0.26, and we're going to divide that by 120. So this one we get 0.04 as our standard error. So the next thing what we want to do, we want to get the z-value. So the z-value, or the test statistic, we're going to get it by doing z is equal to p hat minus p, all divided by standard error. So p hat is equal to 0.208 minus p, which is 0.26. So remember, p is always the proportion of what they're claiming. So since they're claiming is 26%, that way we put 0.26, and we divide it by standard error, which is 0.04. So once we get this z-value, we're going to look for the p-value. So if you haven't already gotten your z-table, please get the z-table, because you're going to be needing it for once we want to get the p-value. So we could do 0.20a minus 0.26, and we're going to divide that by 0.04. So if we do that, we get a z-value which is negative 1.3. So if we kind of forgot, we kind of want to draw a density curve, because the density curve is going to tell us what side of the proportion we want. So negative 1.3 kind of falls over here approximately. So we want to find out which side should I shade. Should I shade the left side, which is here, the left side, or should I shade the right side? So an easy way to kind of distinguish if you should shade the left side or the right side, just look at your alternate hypothesis. And just look at the arrow. The arrow will tell you what side to shade. Since the arrow is saying less than, you shade to the left. So this is telling me any proportion I get from the z-table, I'm not going to do the 1 minus or the complement rule to it, because the proportion that the z-table is going to give me is actually the proportion that I want. So let's look at the z-table. So for the z-table, we're looking for 1.3. So if you look at negative 1.3 is somewhere right here. So let's see. So we're looking for 1.3. So I'm gonna just highlight it. So if you look at negative 1.3, we get 0.096a. 0.096a. So you get 0.096a. So this is my proportion, which is what I wanted. This is my z-value, and this is my p-value. So we just want to find. So we just want to find which one kind of encapsulate that. So if you look at A has the p-value, and so if you look at A has 0.20a. It has a z-value which is negative 1.29, which is pretty close to what we got of negative 1.3. So for this one, the answer will be A because A is giving us a negative 1.29, which is very, very close to negative 1.3. And if you look at the p-value are almost identical. It is off by 1/1000 of a percent. So for this one, A will be our final answer. Alright, so I'm going to stop it right here, and then we're going to continue on with number 8.